Now, we discuss about previously Newton's laws we discussed. So, in that force and Newton's first law we discussed. Once again, we have to repeat that and continue the topic. Now, this what happens. Inertia is an important factor here. In first law, inertia is an important factor for first law. What does inertia means? Should I have told you? Then once again I repeat its definition. What is that? The inability of a body to change its state of rest or state of uniform motion in straight line by itself is called inertia. So what is that? The inability of body to change its state of rest. So if the body is at rest, it changes its position by applying the force only. If it is in motion, it will be change its direction. So otherwise to increase its speed. For that, we use this word inertia, or otherwise it can also be defined. The natural tendency of body to remain in the state of rest or state of uniform motion in a straight line is called as inertia. Like that also to be defined. Now, what is this unit of inertia? So in SI system, it is measured in kilograms. Unit of inertia is taken as unit of inertia. Unit of inertia in SI system. In SI system considered as kilogram, and in CGS system considered as gram. In CGS system it is gram, and in MKS system it is kilograms, so have to consider. So here it depends upon the mass. That's why we can use this unit kilogram or gram. Inertia depends on mass. Remember that. Inertia depends on mass of the body. Mass of the body. So it's a very important factor. Mass influences this inertia. So inertia depends on the mass. For example, to observe two different weights contained. For example, one train and one bus will be traveling parallel. So bus is on the road and rail is on the track. Both will be moved with 60 kilometers speed. To imagine that both move 60 kilometers. Train and bus, they move parallel. And on the road, the bus will passes. So we have to observe train and bus side by side will be traveled. So here also to imagine train and bus will be travel on one is track on another is drive with 60 kilometers speed. Now, after some time, they passing way. Brakes are applied. To imagine, brakes are applied. Which will stop quickly? Bus or train? Bus stops quickly than that of the train. Why? Because the mass of the bus is less than that of the train. Yes, mass of the bus is less than that of the train. So, mass of train is very high. That's why. So all compartments will be there. No. So all compartment to stop, then only you can apply to be observed. When the train enters the station, before 1 or 2 kilometers applies the brake, then only it comes and stops. To observe all the engine will be stops far away from the station. Similarly, that last compartment also stops at end of the station. Yes. So what is this? It is a heavy body. So brakes are applied both at same time. But what happens? This lighter body stops very quick, but heavier body stops later. That means inertia will be depends upon mass of the body. Now inertia will be classified into two types. Yesterday also I told you, that is inertia of rest, inertia of motion, and inertia of direction. So inertia of rest means the tendency of a body to continue in its state of rest is called as inertia of rest. For example, when bus starts suddenly, the passenger fall backwards. This is due to inertia of rest. So bus is at rest. The passenger is also at rest. He will be stand in the bus. It is also but bus is not started. So to observe in daily life also I observe this thing. Yes, suddenly the bus will be stopped. What happens? The passenger moves back. This is due to the inertia of rest. That is, when force are applied there, its motion will be comes. So due to that reason, he will move backward. This is called as inertia of rest, we can say. Inertia of motion. What is this? The tendency of the body to continue its state of uniform motion is called as inertia of motion. So, continuous in its motion. That means in its velocity, no change in its velocity, it will be continuously, it will be travels. Such a motion is said to be the inertia of motion. For example, the passenger in a bus falls forward when sudden brakes are applied for moving bus. So if the bus moves very fastly and suddenly applies the brake, what happens? He falls front. So in daily life also I had observed this thing, no? So observe that the difference. The bus is not starting, that is at rest position it will be there. The passenger also in rest position. Suddenly the bus will start. The passenger moves backward. Due to inertia of rest, his force applies back. So he falls backward. Bus moves front, he falls back. And inertia of motion. Inertia of motion means already the bus is in motion. It will be traveled. So that means it travels with certain velocity. When brakes are applied, what happens? Suddenly brakes are applied. The passenger moves front side. So he moves front side due to inertia of motion. Now, inertia of direction. That is the tendency of the body to continue to move with uniform motion in the same direction is said to be the inertia of direction. So, if force is not applied in particular direction only, it will be travels. Understand? If force is not supplied. So, for example, to take the diversion, to take the turn, to apply certain force and to take turn. Okay? Then what happens? Inertia of direction. For example, you observe when the bus going in a straight manner takes a sudden turn, the passenger of the bus falls sidewards. Yes? So in God sections you had observed, so curved roads will be there. So what happens? The bus takes the curve, the passenger falls. So which side it will be? Take the curve, that side he falls due to the inertia of direction. Okay. Similarly, one more example to observe here. When the rabbit suddenly changed its direction, the chasing dog strips down as it could not change its direction suddenly. For example, a dog want to catch down a rabbit. So rabbit immediately, so it's a very small one. So immediately he changes direction and moves faster. But dog does not take turns immediately. What happens? It will fall down. So the dog fell down and woke up. Understand? So at first, ideally it will fall down because it does not have the resistance to continue in its motion to take the turn. So these are the examples of inertia of direction. Now we consider Newton's second law, or otherwise before that we discuss about the momentum. Newton's second law. Newton's second law. Second law, or otherwise law of force, law of momentum. First we discuss about the momentum. First we discuss momentum. It is denoted by the letter P. It is denoted by the letter P. Momentum means the ability of moving body to communicate motion to the another body. So momentum is the ability of moving body to communicate motion to the other body. So other body also comes to motion. Such a movement is said to be such a force applied on it is said to be the momentum, we can see. So the body having more momentum can show more impact or another body on collision. So when two bodies will be collide, so for example in game of marble to observe, to strike one marble with another marble, you had applied very large the force that will be displaces further distance, okay, due to this inertia, momentum. Now this momentum simply to be defined as momentum is the product of mass and velocity of the body. So momentum depends upon mass and velocity. Mass of the body, that is m, and velocity of the body, velocity of the body, that is v. The product of this mass and velocity is said momentum, very important application to remember. Momentum is equal to m into v, the product of mass into velocity. Very important application. P is equal to, second law important applications are there. So remember that. So P is equal to m into v, mass into velocity. Okay. So what is momentum? To define as the momentum, the product of mass and velocity is said to be the momentum of the body. So in general, momentum is said to be the momentum to communicate motion to the another body also to be moved. We had applied this force of that, such a force is said to be the momentum we called. Now in SI system, its units to be considered momentum units of momentum. In SI system, you have to consider mass is measured in kilogram, velocity is measured in meter per second. Therefore, what is the unit of momentum? So P is equal to kilogram meter per second. Kilogram meter per second is its units in CGS system, and in NKS system or in SI system, kilogram meter second. In CGS system, mass is measured in grams and velocity is measured in centimeter per second. Therefore, momentum is equal to gram centimeter per second. Gram centimeter per second is the unit in momentum in CGS system. So momentum is the vector quantity. Remember that it is a velocity is a vector, no? Therefore momentum is also vector quantity. So remember what quantity it is means to remember, it is a vector quantity. Momentum is a vector quantity. Why? Because velocity is vector, therefore momentum is also considered as vector quantity. And now from that we can apply the Newton's second law. So we can prove this Newton's second law of motion. So to consider this Newton's second law. Newton's second law to be said to be the acceleration of the body directly proportional to the net force acting on the body and inversely proportional to its mass. So the direction of acceleration will be in the same direction as the external force acts. So what is Newton's second law says? Acceleration is, as the first point to remember, is the acceleration. What is the letter indicate A? Acceleration is directly proportional to force. F is force, and second factor is mass. M is mass. Mass is inversely proportional to mass. So according to that, we can derive an important derivation, that is derive the formula F is equal to ma. F is equal to ma, we have to deduce. So according to this previous factors, acceleration is directly proportional to its force and mass is inversely proportional to acceleration is inversely proportional to the force, and acceleration is inversely so acceleration is directly proportional to force and mass is inversely proportional to acceleration. Means A is proportional to F, let it be equation 1, and A is proportional to 1 by M, let it be equation number 2 to be considered. Okay. So A is considered. From 1 and 2 equations, A proportional to F by M. To remove this proportionality, compulsory we need a constant. Otherwise, by making cross multiplication, what do you get? F proportional to MA. Like that also happened. F proportional. So by making cross multiplication, M into A. K. So F is equal to kMA, where K is proportionality constant. Remember that. What is K here? Proportionality constant. So K is said to be the proportionality constant. That's also said to be the unit force. That's also called as a unit force to say. So let it be this and equation number 3 to consider. So in this to observe unit force, what do you define this one? Unit force. This K can be, this constant can be represented as a unit force. In this, mass of the body is taken as 1 kilogram and acceleration is said to be 1 meter per second square. Then force acts on that body will be 1 Newton. Then force acts on body is 1 Newton. Now all of these values substitute in 3. All these values to substitute in equation 3. What do you get? F1 is 1 into K into 1 into 1. So what do you get? K is equal to 1. Take it as 4. This K value will be substituted in the equation 3 again. You get F is equal to MA formula. So substitute 4 in 3. You get F is equal to 1 into MA. That is equal to F is equal to MA. So very important derivation. The relation between force, acceleration and mass. Here acceleration is directly proportional to the mass and mass is inversely proportional to the acceleration. Remember these two things. Mass is inversely proportional to the acceleration and acceleration of force is directly proportional to the acceleration. According to that, A proportional to F and A proportional to 1 by M. 1 by M. Now from 1 and 2 equations we get A proportional to F by M. F into 1 by M means F by M. So this the proportionality symbol. Compulsory we remove this. Otherwise it does not become an equation. So if it is not an equation, we can't be calculate the problems. That's why this proportionality to be removed. By removing this proportionality compulsory, we required one constant. So here the constant is K. So for unknown things, constant to be taken as K, or definitely defined terms will be there. For that we can consider other letters also. So in other case, in gravitation topic I will discuss about that. So here this K is proportionality constant and this proportionality constant equation is only F is equal to MA, not F is equal to KMA. That's why this proportionality constant to be removed. By removing that proportionality constant, we can define this unit force. We can define this unit force. Unit means one. One unit means one number to be considered. For example, 1 kilogram, 1 meter per second square acceleration will act 1 kilogram mass of the body. The force acts at that time will be 1 Newton. So all of these values, M is equal to 1 kilogram, A is equal to 1 meter per second square, F is equal to 1. All these values substitute in the equation F is equal to KMA. You get K value is also, all to be substitute here, you get K value is also. Now to substitute this K value 1 in the equation F is equal to KMA, we get F is equal to MA. So that's the relation between force, mass and acceleration. Okay, so that's the relation. Right.